mark. Get set. Let's fry some fish. Hey everybody, welcome to episode number 458 of this here electronic engineering podcast called Amelia's Weekly Fish Fry. Brought to you by eejournal.com and written, produced, and hosted by yours truly, Amelia Dalton. So, when I was a kid, my dad was a huge race car fan. IndyCar, Formula One, NASCAR, you name it. I can just hear that sound in my head as I descend the stairs into our old living room. In the days before DVRs, my dad would get up in the middle of the night just to start our VCR recorder so he wouldn't miss the newest Formula One race. When I was 12, I met my first IndyCar driver, Mr. Eddie Cheever. Oh yeah, I was smitten. So, when I saw this announcement come across my desk, I thought, yes, I need to cover this one. So, this week, I am super happy to bring in Joe Speed from ADLINK to talk all about the Indy Autonomous Challenge, the first autonomous race car competition at the Indianapolis Motor Speedway. Joe and I dig into some of the behind-the-scenes work of this first-of-its-kind autonomous challenge, including the details of the ADLINK AVA-3501 series rugged edge platform that was supplied to each of the teams, and the IAC base vehicle software that was developed together with ADLINK, open source software foundations, and university teams. Oh yes, we're talking about all of this and more. So buckle up and let's bring in Joe. Hi, Joe. Thank you so much for joining me.
Hey, real pleasure. Glad to be here today.
Excellent. Okay, so we are talking about the Indy Autonomous Challenge today, the first autonomous race car competition at the Indianapolis Motor Speedway. Joe, I'm super excited. So ADLINK was the official edge computing sponsor. So first, can you set the stage for us? Tell my audience more about this challenge and what was the overall goal of the IAC?
Sure, happy to. So the way this got started, so there's a fellow named Sebastian Thrun, who's really like the godfather of modern autonomous driving. So Sebastian and his Stanley team from Stanford had won the DARPA Grand Challenge, where autonomous vehicles going through the desert some years ago. So he was out here at the Indy 500 and he had commented to somebody that, a lot of things happening in autonomy are just not that exciting. Don't get me excited the way I used to be. But this, if the Indy 500 was autonomous, like I would watch that. That would be really exciting. And so that's how this all started. So the people here in Indiana, the Indiana Economic Commission, I suppose, and many others, and IMS, Indy Motor Speedway. So if I ever say IMS, talk about the Indy Motor Speedway. And others, they had this idea of doing something in the style of a DARPA Grand Challenge. So what they did is they set out to build exactly identical cars for all the teams, and that the university teams would develop their own software for the cars, and that they would then come and race it. So there was a series of simulation challenges and awards and prizes for that. And then the big competition tomorrow is actually, I believe it's $1 million to the winning team of students. So basically think of it as this is a university software contest that gets played out at, 150 plus miles per hour.
I love it. So Joe, let's dig into some of the behind the scenes work that has taken place at ADLINK in relation to this challenge. So you guys supplied each team with an ADLINK AVA-3501 series rugged edge platform. So can you give me some details about this platform in particular and what kind of benefits it provides to the teams?
Sure. So AVA is our product line for autonomous vehicles, 5G driverless, connected car, all these kinds of things. So our AVA line of products are developed for vehicles. And when Gina O'Connell of Indy Autonomous Challenge, Gina and I have done like so many crazy projects together in the past. We did a 3D printed self-driving bus for the elderly and disabled, and Stevie Wonder came and hung out with us in it. We've done all kinds of connected cars, autonomous vehicles, all kinds of things. So Gina comes to me and is like, I really think you and ADLINK should be part of this program. And so I looked at the requirements, like the kinds of sensors that they were looking at, the speeds they were looking at. And I thought that our existing vehicle products were not powerful enough for what I want the teams to be able to do. So what we did is we designed and made a new product specifically for the Indy Autonomous Challenge. And we manufactured a large number of them and donated them to the program. So the computers in every car, for every team, for the test bench, the spares, all of that was donated by ADLINK. And so that's a rather high spec piece of gear that, among other things, includes a $5,500 NVIDIA RTX 8000 GPU with 48 gig of RAM from our friends in the NVIDIA embedded group. So Paul Griffith and those folks. And so we made the computer, we gave that to the teams. But one of the things that was very clear to me early on is this idea of we just manufacture the race cars and give them to teams and they figure the rest out. Like, that's actually not going to work. So I knew from previous experience that what the teams need is base vehicle software. We need to be able to give the teams an open source stack of software that they can take, and without any more development, the car is at least capable of doing what's called a yellow flag lap, so a low speed lap of the Indy Motor Speedway. What we didn't want is we didn't want students trying to figure out, like, how do I get the cameras working? Why is the radar slow? Why am I dropping messages? All these kinds of issues. So we try to support all of them with the software so they can focus on more interesting problems like, how do I make the car go faster? What's my physics model? How do I do my race car path planning? All of these kinds of things. So, just help them focus on the more important things. So what we did is myself, Josh Whitley of AutoWare Foundation, Kat Scott from Open Robotics, Andreas from the Eclipse Foundation, the Open Autonomous Driving Work Group. We all worked together to provide an open source stack that all the teams can use. And that's what's in the cars today. So all of the teams are running Open Robotics ROS 2. All the teams are running it with the Eclipse Foundation's Cyclone DDS ROS middleware, with the Zeno V2X, which is a plugin that allows them to communicate over the Cisco Curb radios, so the high bandwidth Cisco radios. Many of the teams are using the AutoWare autonomous driving packages, including the interface to the drive-by-wire system. And so I'm just really thrilled at how the community, my community, the open source and robotics community, has banded together to support all of these hundreds of students.
That's fantastic. Now, ADLINK also brought together open source software foundations along with those university teams to develop the IAC base vehicle software, right? So can you tell my audience a bit about this software as well?
Yeah. So like I was saying, the stack of the ROS 2 with the AutoWare autonomous driving packages, with the Eclipse Foundation's middlewares, things like the Cyclone with the ISROX zero copy with the Zeno. These are things that are already used in robotics, already used in vehicles today. But Indy Autonomous Challenge really pushes it into new territory, right? So when you talk about mobile robots, like a mobile robot in a factory or warehouse is typically doing at most, like on a good day, they're doing 1.5 to 2 meters per second. Here, we're talking about vehicles that are capable of doing, I think, like 83 meters a second, right? 200 miles an hour, 330 kilometers per hour. So you start to get into all these things like, let's say the car takes a picture of where it's going. If it takes long to process the image and to do your ML inference on it, you might actually already be past the thing you were looking at by the time you know about it, right? So, you can just imagine if your LiDAR, your radar, your cameras, if the processing pipelines for those are slow, then you're not looking ahead, you're actually looking at where you've been. Because by the time you process it, you'll have already passed that location. So the whole community, the foundations, the Eclipse Foundation with the middlewares, the Open Robotics with the ROS 2, AutoWare with the drive-by-wire interface and other packages, localization and such, we've all had to work together to make these things perform sufficient for this. And there's a lot of education we had to do, right? These are students. These are not like 10 and 20 years robotics industry veterans. So, we had to teach them ROS2. We had to teach them about what is DDS and how to use it, and how do you set up the DDS middleware so that traffic that is local to the car stays in the car and you're not trying to send it over the Cisco radio. It's been a big, heavy lift. Me and the community have been working on this program for over a year. And we're going to see the fruits of that on Saturday, October 23rd here. And I know this podcast probably comes out after, but there is a live stream tomorrow, and that'll be recorded and will be available for replay as well.
Perfect. I was just about to ask that. So besides ADLINK, what other companies were involved?
There's a bunch, and I'll probably miss a few names, but I'll try. So the race cars are the monocoque carbon fiber is made by Dallara, who makes all the Indy cars. So those are made at Dallara's factory in Parma, and then those are flown to Indianapolis, where the race cars are assembled by Juncos Racing, which is an amazing team. I can't say enough about Lauren and all the people there and how great they've been. So they actually build the race car. Then the race cars are put on a truck and taken to Autonomous stuff in Peoria, Illinois. So Autonomous stuff, they're a division of Hexagon. Hexagon makes a lot of sensors, and they make the Novatel GNSS used in the race cars and the like. But Autonomous stuff is like a autonomous driving system integrator. And so what they do is they take the race cars and they install all the computer, the drive-by-wire system, all of the sensors, and I'll tell you about those, and make sure all that works. And then they bring it back to Juncos to do the break-in testing before they're handed over to the teams. And then Juncos is constantly working with the teams, as is Autonomous stuff and the rest of the technology providers, just supporting them, iterating, troubleshooting, solving, making improvements. In one sense, you could say they're race cars, but you could also say they're rolling laboratories. So, they're encountering new problems. They're pushing a lot of the technologies into areas that they've never been before. So you got Autonomous stuff. I mentioned we make the computers and support those. So we provide those to Autonomous stuff for all the cars. You've got Schaeffler Paravan with a drive-by-wire system. So all the actuators, the throttle, the brake, steering, and these things. That is front-ended by what's called a safety MCU from a company called New Eagle. It's their New Eagle Raptor product. And they have helped contribute a open source interface to that to AutoWare. So this is kind of brilliant because anyone who uses ROS2 and the AutoWare drive-by-wire interfaces, it will work with any vehicle that has a New Eagle Raptor installed in it. So not just race cars. You can take this and put it in minivans, passenger vans, trucks, all kinds of things. So you've got New Eagle Raptor. You've got Novatel, which is a division of Hexagon. They make the GPS, the GNSS, with IMU, Inertial Measurement Unit. There's actually two of them, and they each have two antennas. So one of them has antennas mounted fore and aft, so on the front and back of the car. The other one has antennas mounted left and right. And so with that, they can really incredibly accurately not just tell you the position of the car, where the car is, but where it's facing if it's drifting through the turns. Like, there's an incredible amount of information we get from the Novatel. You've got the Luminar LiDAR. So these are 120-degree flash LiDARs, and there's one forward, and then there's two pointed. There's one that's kind of left rear, and there's another that's right rear. And between them, that gives you 360 degrees of coverage for the LiDARs. So you can generate those very high-quality point clouds that can then be used by the AutoWare localization in ROS2. You've got Allied Vision with the Mako cameras. We have 6 cameras. There are 2 cameras pointed forward. So that gives you stereo vision, which is very important for some of the teams. So you've got stereo vision, and then the other 4 are just pointed around. So you get 360 degree of camera coverage. And there is a Cisco Curb radio, formerly a company called Fluid Mesh. So that's a high bandwidth radio. And that's actually how we do things like race control. It's how the teams get telemetry off the cars in real time. It's how, when the car's not in autonomous mode, the teams will actually follow the race car in a chase vehicle with a laptop connected to the Cisco radio and use an Xbox controller to drive the race car. So you're driving $1 million robot using an Xbox controller. So that's pretty fun. And then all of the sensors are connected to a Cisco industrial switch in the car. And that Cisco industrial switch is then what front ends the ADLINK computer. You also have active radars, and there's 3 radars. So there's a long distance radar on the front, and then wide angle radars left and right. And all of those are connected on CAN bus directly to the ADLINK computer. Although actually, I shouldn't say directly. So Cavassar AB of Switzerland, they make the world's best CAN adapter. It's just brilliant work. And so the drive-by-wire system, the radars, all of that are done by Cavassar CAN adapters that were donated by them for every single race car to support the program. And then you've got the rest of the car, and that's the stuff I don't know as much about. So, Bridgestone tires, every car has a great little power plant, twin turbo, making 365 horses. And there's a lot of other parts in that. The autonomous bits I know really well. All the bits that make up the actual vehicle, I don't know as much about.
That's quite okay. So, Joe, this is more than just a competition, right? ADLINK also hosted the STEM Garage. Now, can you give me some details about the STEM Garage and the other elements involved in this challenge?
Yeah, so the STEM Garage is pretty brilliant, actually. So ADLINK is a sponsor. We get a bay. So a bay is like, 23 feet wide, 44 feet deep. And each garage has 3 bays. But we didn't want to do some, like corporate promotion, whatever. Like, we're in this for the universities, we're in this for the kids. And the governor is bringing high school students, so STEM and robotics club students from all over the state of Indiana. And so what we did is we got our friends together. So we got our friends Boston Dynamics, Gaia Platform, the AutoWare Foundation, Cavassar, the F-110th Foundation, which make sure I tell you about that. It's brilliant. EV Grand Prix Autonomous, which is an autonomous racing league invented by Purdue University right here in Indiana. And so what we've done is we've set up a huge trackside right on pit row, this huge garage that is a STEM garage. So it's got robotics exhibitions. It's got hands-on labs for the students. We have an F-110th racetrack. So F-110th, if you've ever seen like a little Traxxas 1/10th scale remote control race car, what we do is we take those and we put an NVIDIA Jetson and a camera and a LiDAR and other things, and we turn it into a little autonomous race car. And so the kids can all see that like those $1 million things out there doing laps of Indy Motor Speedway, if you want to get into it, you can do F-110th. And so we have a bunch of those cars and some hands-on for the students with those as well. And we set up a racetrack. It's like a 20 by 30 foot racetrack here at the racetrack.
That is super cool. All right. Well, Joe, I think it's time for your off-the-cuff question. Now, since you haven't been on my show before, let me throw at you my COVID special. So if you could have one meal right now, Joe, doesn't matter if the restaurant is closed, it's on the other side of the country, you need a passport to get there, what would you have?
This is a difficult one. The best meal I've ever had in my life was at a Malaysian restaurant in Amsterdam, and I can't remember the name of it. And so it absolutely kills me. But it was this curried prawns dish. And I've been to other Malay restaurants and I've never found anything approaching it. So that's a cross I must bear. In terms of things that are more accessible, like I'll drive to the other side of the state for a good chicken mole.
Nice. Well, Joe, I think that's all I have time for today. Thank you so much for joining me. This is super cool.
Hey, it's a real pleasure. Anytime.
If you want even more information about the Indy Autonomous Challenge, I would encourage you to check out the links on this week's Fish Frying page on eejournal.com. Oh, and before we go, don't forget to check out my new maker-themed monthly Fish Fry podcast series called Makers Today. In our 5th episode of this series, I chat with Guido Bonelli from Dr. Duino. Guido and I chat about how art and electronic design intertwine in his life, how his Dr. Duino brand got started with a little help from Kickstarter, what his creation, the Goonie Box, is all about, and how the COVID-19 pandemic inspired him to create the Social Distancing Arduino Project. Hey, have you checked out EE Journal on social media yet? Well, you should. You can find us at facebook.com/EEJournal. If you're into Twitter, you can monitor our tweets at EEJournalTFM. And don't forget, if you want to follow my personal Twitter account, check out Amelia D. 1978. And hey, if LinkedIn is more your thing, sure, I dig it. You can follow us or me on LinkedIn as well. And we have a YouTube channel, youtube.com/EEJournal. Folks, it is chock full of all kinds of techie videos, including our very popular Chalk Talk webcast series, hosted by me. And you can subscribe to our EE Journal YouTube channel as well. Also, by clicking the links below the player on this week's Fish Fryin' page, you can subscribe to this here podcast through Spotify, Podbean, or Apple Podcasts. And remember, if you'd like to further support this podcast, please leave me a review on that podcasting platform of your choice. It really does help. Thank you, everyone, for tuning in. If you know of any cool new technology or heck you just want to chat, shoot me a line at Amelia, that's AMELIA, at eejournal.com, or post a comment on our forums on EE Journal. For the week of November 19th, 2021, I'm Amelia Dalton, and you've been fried.